1125 11925 upon 53. So again 53, this 53 and this 53 will be cancelled out. You will get 105 divided by under root 11925. So that's why V3 upon norm V3, that will become 0, 30 upon under root 11925 comma 105 upon under root 11925. So this three vector are actually our required orthonormal basis. Okay. So using Gram-Schmidt process, we convert the given basis into orthogonal set of vectors, and from orthogonal set of vectors to orthonormal set of vectors, for that you have to divide each vector divided by its norm. Okay, so here these three vectors are our orthonormal set of bases. Okay, so this question is complete. Next question 4a, second part. For U, this capital U, that is equal to U1 U2 U3 U4 set of 2 cross 2 matrix, and V is equal to V1 V2 V3 V4 in set of 2 cross 2 matrix, defined. Here inner product is defined by this definition. We have to use this definition. Inner product UV, that is equal to U1 V1, see U1 into V1 plus U2 into V2 plus U3 into V3 plus U4 into V4. Okay, so we define inner product between this two set of 2 cross 2 matrix with this definition, that inner product UV can be written as a U1 V1 plus U2 V2 plus U3 into V3 plus U4 into V4. Now for the matrices A and B, verify Cauchy squares inequality and find the cosine of the angle between them. Okay, so first of all we have to verify Cauchy squares inequality, and then we have to find the angle between these two matrices, where A is equal to 2 6 1 minus 3 and B is equal to, in set of 2 cross 2 matrix, 3 2 1 0. Okay, so what is Cauchy squares inequality? Cauchy squares inequality for U and V vector, that is equal to modulus of inner product UV, that is always less or equal to norm U dot norm V, right? So instead of U and V, here we have matrix A and B. So for that, first of all you have to verify that modulus of inner product AB, that is less or equal to norm A into norm B. Okay, so that's why, see, first of all we have to find inner product AB, that is equal to 2 into 3 plus 6 into 2 plus 1 into 1 plus minus 3 into 0, using this definition U1 V1 plus U2 V2 plus U3 V3 plus U4 V4. So that's why we use this definition to find inner product AB, that is equal to 2 into 3 plus 6 into 2 plus 1 into 1 plus minus 3 into 0. So that is equal to 6 plus 12 plus 1 plus 0, that will become 19, right? So inner product AB is equal to 19. So this is positive value. So when you take modulus, that is also equal to 19, right? So call it equation 1. So we will get inner product modulus of inner product AB, that is equal to 19. Now find norm A square. Norm A square. Now norm A square can be written as inner product A with A. Okay, that you should know that norm in general, norm U square in inner product space, norm U square can be written as inner product U with U for all U belongs to vector space V. So here same situation happen. We have to find norm A square. So norm A square is equal to inner product A with A, that is equal to, right? So here our A is 2 6 1 minus 3. So when you take norm A square, that is equal to inner product A with A, that can be written as 2 square plus 6 square plus 1 square plus minus 3 square. So 2 square plus 6 square plus 1 square plus minus 3 square, that is equal to 4 plus 36 plus 1 plus 9. Okay, that will become 50, right? 36 plus 4 40 plus 1 41 plus 9, that is 50. So norm a square is equal to 50. So norm a, that is equal to under root 50. Similarly, you can find norm b square, right? Norm b square, that is equal to inner product b with b. So here is our b matrix 3 2 1 0. So norm b square can be written as 3 square plus 2 square plus 1 square plus 0 square. So that's why norm b square is equal to 3 square plus 2 square plus 1 square plus 0 square, that is equal to 9 plus 4 plus 1, that is equal to 14. Okay, so now norm b square is 14. So norm b is equal to under root 14. Now find out norm a into norm b, right? Norm a is under root 50 into norm b, that is under root 14, that is equal to under root 50 into 14, right? So that is equal to 700. So under root 700, that is equal to approximately 26.46, right? So call it, this is equation 2. Now from 1 and 2 you can see that what is modulus of inner product AB, that is 19, and what is product of norm A and norm B, that is 26.46. So clearly you can see that from 1 and 2 modulus of inner product AB, that is less or equal to norm A into norm B. So here Cauchy-Schwarz inequality is verified. Okay, that is exactly the Cauchy-Schwarz inequality. So here we verified the Cauchy-Schwarz inequality for the matrix A and B. Now we have to find angle between A and B. So for that we have this formula. If theta is angle between A and B, then cos theta is equal to inner product AB divided by norm A into norm B, that is equal to inner product AB. What is inner product AB? We already find this is our inner product AB, right? 19. See, so we put all these values. Cos theta is equal to inner product AB divided by norm A into norm B. So put all this value. Inner product AB is 19. Norm A is we know that under root 50, and norm B is under root 14. That is equal to 19 upon under root 700, and that can be written as 19 upon 10 into under root 7. So cos theta, that is equal to 19 upon 10 into under root 7. So if you want to find angle between these two matrices, then you can say that theta, that is equal to cos inverse 19 upon 10 into under root 7. Okay, so here is a complete the solution. Next question, question number 4b, first part. Find the least square solution of the linear system Ax is equal to b, and find the orthogonal projection of b onto the column space of A, where A is equal to 1 1. This is a 3 cross 2 matrix, right? Number of row is 3 and number of column is 2. Clear? So where A is equal to 1 1 minus 1 1 minus 1 2, and B is equal to 7 0 minus 7. So this question asking 3 marks. Here is the solution. A is equal to 1 1 minus 1 1 minus 1 2, and x, call it x is equal to x1 x2, and B is 7 0 minus 7. So now find A transpose. This, the matrix A is in form of 3 cross 2. When you transpose of this matrix, the new matrix A transpose become 2 cross 3 matrix, right? A transpose, that is equal to 1 minus 1 minus 1 1 1 2. Okay, the normal equation are given by A transpose. We have to use this equation, right, to find least square approximation, right, least square solution of the linear system, and then find orthogonal projection of B. So for that we have to use this formula. Normal equation are given by A transpose into A into x caret, that is equal to A transpose into B, right? Now put all this value. A transpose, here is A transpose, this is A, x caret, that is x1 x2, that is equal to A that is 1 minus 1 minus 1, 1 1 2 into 7 0 minus 7, right? First of all, we have to multiply this two matrix, right? See, this matrix is in form of 2 cross 3, this matrix is in form of 3 cross 2, right? So I hope that you can understand how to multiplication of two matrices. The number of column in this first matrix 3 and number of row in second matrix, that is also 3. So that's why we can multiply this two matrix, otherwise not. The number of column in the first matrix, right? When you multiply A and B, the number of column in A and the number of row in B, that two are same, right? So here the number of column in the first matrix, that is 3, and number of row in the second matrix, that is also 3. So that's why we can multiply this two matrix, and our new matrix is in form of number of row of the first matrix into number of column of the second matrix, right? So our new matrix become 2 cross 2. Why? Because the number of row in the first matrix is 2 and the number of column in the second matrix is also 2. So that's why our new matrix become 2 cross 2. How we multiply this two matrix, that you have to understand. Now just take first row of the first matrix, right? Take first row of the first matrix and multiply each and every column of the second matrix, right? So just take first row of the first matrix, that is 1 minus 1 minus 1. Now we have to multiply each and every column of the second matrix. So in second matrix we have only two columns, so we have to multiply in both the column, right, with the both the column. So 1 minus 1 minus 1 into 1 minus 1 minus 1. So 1 into 1, 1, plus minus 1 into minus 1, that is minus 1, plus minus 1 into minus 1, right, that is also minus 1 into minus 1, that is 1, plus minus 1 into minus 1, that is 1. So you will get 1 into 1 1, plus minus 1 into minus 1 1, plus minus 1 into minus 1, that is also 1. So you will get 1 plus 1 plus 1, so 3, right? So the first entry is 3. See, this is 3. Okay. Now multiply this first row with second column, right, one by one. So 1 into 1 1, plus minus 1 into 1, that is minus 1, plus minus 1 into 2, that is minus 2. So that's why you will get 1 minus 1 minus 2, 1 minus 1 minus 2. So 1 minus 1 will be cancelled out, just remaining part is minus 2. So that's why you will get minus 2, right? Okay. Now we already multiply this first row with both the column. Now there is no another column. So now take second row of the first matrix, 1 1 2, and multiply each and every column of the second matrix. So 1 1 2 multiply with first column of the second matrix. So 1 into 1 1, plus 1 into minus 1 minus 1, plus 2 into minus 1 minus 2. So 1 minus 1 minus 2, that will become minus 2. Okay. Then multiply this second row with the second column. So 1 into 1 1, plus 1 plus 4. So 1 plus 1 plus 4, you will get 6, right? So here is our new matrix, multiplication of this two matrix, that is actually 2 cross 2 matrix, 3 minus 2 minus 2 6 into x1 x2, that is equal to 14 minus 7. How we will get 14 minus 7? From this two matrix. See, this matrix is in 2 cross 3, this matrix is in 3 cross 1, right? So clearly the number of column of the first matrix and the number of row of the second matrix are same. The number of column of the first matrix is 3, the number of column of the number of row of the second matrix is also 3. So that's why you can multiply. Take first row and then multiply with this column. So 1 into 7, 7, then 0, then plus 7. So that's why you will get 14. Then 7, 0, minus 14. So that's why you will get 7 minus 14, that is minus 7. Okay. So now x1, x2, that is equal to, put this value in the right hand side, or in other words, multiply in both the side inverse of this matrix. 3 minus 2 minus 2, 6. So left hand side you will get identity matrix, right, and right hand side you will get inverse of 3 minus 2 minus 2, 6 inverse into 14 minus 7. Now inverse of this matrix is quite easy to solve, because in 2 cross 2 matrix, if you want to find inverse of this matrix, just you have to first of all interchange this main diagonal entries. So here 3, 6, just interchange. So you will get 6 and 3, right, and then change the sign of this another diagonal. So minus 2 become now 2, 2, divided by its determinant. What is the determinant of this 2 cross 2 matrix? See, 6 into 3, that is 18, minus 2 into minus 2, that is 4. So 18 minus 4, that is 14. So inverse of this matrix is actually 6, 2, 2, 3. Okay, this is adjoint and this is determinant. Inverse of this matrix can be expressed as adjoint of A divided by its determinant. Multiply with 14 minus 7, right. So multiply this two matrix now. This matrix is in 2 cross 2, this is 2 cross 1. So you can multiply this two matrix, right. It satisfied the rule of the matrix multiplication. So 6 into 14, right, 6 into 14, 84 minus 14, right, 6 into 14, that is 84, minus 7 into 2, that is 14. So 84 minus 14, that is 70. Then 2 into 14, 28 minus 21, 3 into minus 7, that is 21. So 2 into 14, 28 minus 3 into minus 7, that is minus 21. So you will get 7.